Okay, I have some vocal. And as I had mentioned last week, it was quite possible that I was going to have to do a pre-recorded session uh, for this coming Monday, the 16th. The simple reason is I have a meeting at 10 o'clock, and I probably will not get out of it in time to get up there quickly. And so I thought I'll go ahead and pre-record a meeting for today, the 16th. And basically, and then of course we'll have the usual. So next week you'll have a pre-recorded session from me, and then on Wednesday I'll do a live screencast. Hopefully we're back to some normalcy in the schedule. Well, there's some things that I want to cover, and first of all, I want to look at the Hammond's port, and we'll look at the screenshot. Now, I also have a link to Hammond's port 1, okay? And again, let me get the textbook up here, which is my virtual textbook. There we go. And I'll move a couple of things over here. All right. And there's the bookshelf. And we'll take a look at I'll sign myself in. And there we go. Introduction management. And here we are. We're back over here at page 569. And this is Hammond's port 1, okay? And this deals with, we had looked at using simulated data, okay, to model arrival times. And this is for a savings bank with a single arriving time, all right? And here we're given the flow chart. Now we're back over on page 565, and we're shown, the normal distribution, probability distribution, where we've got service time in minutes and the standard deviations, and then the customer service times, and that we generate these using the normalized norm inverted function with the RAND function, okay? And so we generate a customer service, we can generate customer service times. And now here's the simulation model, okay, where we have the number of ATMs, the arrival time, the service time, and then we look at the operating characteristics. Now, back over here again in chapter 12, page 566, the authors walk us through a flow chart now, okay? And we see, and this is just basically, it's like a counter, if you will, or a clock, and you could see the decision nodes. It's a flow chart, and the outcomes, the start, the new customer, the next customer, and we walk them through, see them walk through the system to the point that they exit the system. Now, the authors even go so far over here on page 568, if I'm not mistaken, to walk you through, okay, each customer, the inter-arrival time is generated. Then before the simulation run begins, I'm customer 1 is 0. The arrival time for the customer 1 is 1.4. So 0 plus 1.4 gives 1.4 minutes. And then they walk us through the math for each customer 1, customer 2, customer 3. seeing these service moments and arrival moments. Then the authors walk us over here to Hammond's port 1, okay, and here they calculate and they generate they simulate 1,000 customers the arrival time, enter arrival time, the arrival time, the service start time, any waiting time, the service time, and then, of course, the completion time and the time in the system. And then below are summary statistics, which include the number of people, number waiting, the probability of people of waiting, the average waiting time, maximum waiting time, etc. And then they show us a histogram of that distribution. Okay, so that's Hammond's port 1. Now I'm going to go over here to the course files. I'm just going to show you that I have a screenshot for you. I also have a video on Hammond's port 1, so you'll want to look at it, all right? And here's a screenshot. And we can zoom this up. Pardon me, zoom it out. Let's just download it. Probably going to be easier. Okay, and let me go back here. I'll move this over, enable the editing, and here's our solution. Okay, and that shows us the solution for that Word doc as it's shown in the Word doc. Now what I want to do is I'm going to close, I'll enable the editing, and this lets us size that up, okay, and it lets us see where we end up with in terms of the key. All right, now I'm going to close this off for a minute. I don't want to say this. We'll get this, and we'll go back. And I want to go down to down here to the key, and I'm going to publish it so you can see it. I'd ask you to do a little work with Hammond's port if I'm not mistaken. In fact, I'll download this and we'll take a look at it. Okay. And I'm going to enable the editing on it, excuse me. And here we're going to see, I'd ask you to use the goal seek to obtain a probability of waiting to 0.55 by using the largest value for inter-arrival times, and then to use goal seek to obtain the maximum waiting time. Okay, and that's what we had gotten done there when we looked at that key, and we won't save it. Okay, so we'll go back now. All right, and of course, we also looked at single arbitrary. Okay, and we talked about it. So we also looked at Hammond's port. Now we also found a p-value, because what we end up doing, and now this single arbitrary key, I want to talk about it for just a moment because this is from this week. And we had, of course, had gotten right. We've handled Hammond's port 1. We talked about the support center. That's that outliers. That's from DataSmart. Okay, and I had some resources there for you about how long customers wait. So we're down here in module 11 now. Okay, and we looked at the key for Hammond's port 1, which was due today. And then also Hammond's port 2, but Hammond's port 2 will be due on the 20th. So we looked at Hammond's port 1, and we looked at the key. All right. Now, Hammond's port 2 is also going to be due on the 20th of April. So let's look at it for just a moment. And here I am asking you to use a goal seek to obtain the number weighting to 70 by changing the standard deviation for service time. So I'm having you manipulate some of those variables as we've done before. Hammond's port 2 is over on page 570 in the text. Okay, and here they begin to talk about simulation with 2 ATMs, not just one. Okay, and we have time ATM 1, ATM 2. And then they walk us through these customers 6, 7, and 8. And again, where we got the arrival times, etc., and we get those averages. Now they show us the simulation results, okay, with 2 ATMs. And I'm going to go over here into the files, okay, and I'm going to go back into the file, all right, and I want to pull out so let's go to the files section, and we're going to Hammond's port. Well, what we need to do is just go down here and get the MIS web files. Here they are, and we'll get Hammond's port 2. And the main thing here is, and this is chapter 11. And we're going to open it up. And the Excel files, we'll open those up. And let's see, Hammond's port 2. Maybe it's going to be in 12. Let's go look here for a minute. Hammond's port 2 is what I'm after. There it is, Hammond's port 2. My apologies. All right, so we'll close this down, and I'm going to take Hammond's port 2. All right, and I'm going to put it on my desktop. I'm going to close this off, and here's Hammond's port 2. And I'm going to open it up now. Okay, and let's walk through here real quickly. Here's the smallest value, which is obviously 0. Here's the largest value. So we start with we build a continuum. This is in terms of enter arrival times. And we assume that it's a normal distribution. And so since we can have a mean and then a standard deviation. So we assume that service times run between somewhere of 2.5 minutes and 1.5 minutes. Okay, that would be 1 sigma or standard deviation 1, plus 1, minus 1 standard deviation. When we come down to the simulation again, don't let this fool you. What they've done here is the authors have simply hidden all the cells, so they give us the first 5 customers and then the last 5 customers. And we see, and we'll look over here at the enter arrival time. And I'm going to take this for a moment, all right? And I want to copy it, and I'm going to put it on a notepad so we can kind of look at it a little bit easier, okay? And I'm going to take this notepad and adjust it over here, okay? Now, the enter arrival time, it equals B4, okay? And we have that $4, so let's look at that for just a minute up there. I'll go find B4, which is the smallest value, okay? Plus some randomly generated number. Now we're using the rand function. So we're generating a random number times B5, which is the largest value, minus B4, okay? So we're going to take B4 plus the random number, and we're going to take that times B5 minus B4, okay? And we'll get out of that for a minute. And then we get 2.5. Now I want to put this back up here for a minute because you can see we're looking at, okay, B4, which is 5 times some random number. And that's times B5 minus B4. And we get the enter arrival time. Okay, and that's at 2.5. Now, as we go through the iterations here, okay, you'll notice something. Let's look here at customer number 2. Customer number 2 comes, and their enter arrival time is 3.1. Okay, their arrival time is 5.6. Their service time is 5.6. Service start time, excuse me. Their service time is 1.7, so they're completed in 7.3 minutes. The time in the system, consequently, is 1.7, okay? And I'm gonna click the cell so you can see them, because they spent 5.6 minutes waiting to be served, and it took them 1.7 minutes to serve them. So that's their time actually, and they get their completion time. So the time in the system, okay, the time in the system is going to be G17, and that's the arrival time, minus C17, okay. The arrival time for customer number 2, okay. And we have that equals G17, and G17, pardon me, is going to be the completion time for customer 2 minus, okay, C17, which is the arrival time. And we get one for each teller. Now notice as I go in here, these data are volatile, okay? And we use an if statement here. Right. And this is just a matter of the random function there. That random function, okay, of the enter arrival time is the seed or sets in motion this process of calculating enter arrival time, the arrival time, the service start time, the waiting time, the service time, the completion time, and it walks us through it. Now, at the end of all this, because we assume up here that the enter arrival times are normally distributed, we can then go ahead and count and get the number of number waiting. And here we use a count if, okay, E116 to E105 is greater than 0. And we count them. So if E116, and we'll come down there, all right. Pardon me, E116, we'll scroll up here to E116, is greater than E105, then we count it. Because we start it. And we use the count if number. Then we get the probability of waiting. And so it's just simply we get an average and the maximum number weighting. And we're still working with that array, with that set of data E116 to E1015. And here we get this, we use the sum to calculate, this formula calculates for us the utilization of the ATMs and the number of those waiting more than a minute and the probability of that happening. That's pretty much the whole secret is understanding how these all work together, okay, and then applying the random function, and that's really so. In Hammond's port 2, I ask you to do some work with that, and we'll close that off. We'll go back in here, okay, and I'm going to ask you to do a little more manipulation with this and see what you get. Remember now, I'm doing this for the 16th, the 18th, and the 20th, although I'm posting it early. This will be pre-recorded. So we looked at the key for Hammond's port 1. There's the video, and then you'll be uploading Hammond's port 2, and we've taken a look at it. Okay, and then that case we've worked with two arrival times. I have some resources here for you as well about Little's Law on queuing theory. I talked about this, how Southwest Airlines changed the airlines with and that's with reducing their downtime. Here are all types of resources about Poisson distributions, queuing theory, waiting line models. I also have some information here about the normal distribution and the norm inversion. Okay, and that's a function that we use in Hammond's port 2. Okay, and so those are the things that will be due for the 16th. Pardon me, on the 20th. And let's see what I ask you to do. I'm going to open up the hands. Here we are. I'm going to ask you to use the goal seek to obtain the number weighting to 70 by changing the standard deviation for service times. And let's see what you get. And that is due on the 20th. A week from today. Now, since I've got you here and I've got some time, all right, I also want to talk about looking ahead at the course, all right. Now, I'll be doing a screencast Wednesday. This will be pre-recorded. I'll do a live screencast on Wednesday, and probably what I will do, okay, is I may take some time, okay, to talk about the tree plan and what that and how that works. Okay, and the reason being, we're moving down to that time. In fact, the week of the 23rd is flex time. and the class sessions will be pre-recorded for you to take a look at. That's so you can begin to work on these projects that are due. Now the work is due that's due. For example, on the 23rd, on the 23rd, let's see what you've got due. You've got some the PDC project that's due. I'll do a screencast on it. Then you have chapter 13, 14, and 15. Those are due. Okay. And while I'm covering that, I will also walk through again the SAP Business One part instructions, and then the Anderson text STQ. But we won't be doing any live class sessions. These will be pre-recorded, okay? And then you can that's flex time. You say, well, what should I be working on? Well, you're going to need to be working on the SAP Business One assignments, okay? And then, and again, these assignments will be pre-recorded out. So the time you would spend in class, you should be working on. And here they are, SAP Business One. Here's the Anderson text self-developed quiz. That's going to be due. And as you notice, then we move into the finals. So I'm also going to give you time, okay, to do the finals. So I'm going to do a live screencast. They'll be pre-recorded, and so I may even, I'm going to do a screencast that'll be pre-recorded. I may even do them during the regular class times, but you're not bound at all to be there. Okay. I'll probably do those, and so you'll have these assignments, and you can do work on them. Okay. So I'm trying to what I'm trying to do is get you to a point where if you know what's due, okay, and you've got these resources, but then you can start to move, because we move into flex time mode on the 23rd, 25th, and 27th, which is, so this week of the 16th, 18th, and the 20th is the last week that I'll do a live screencast. Okay, I'll do pre-recorded screencasts. I'll post them. It'll be up to you to get the work done that you need to get done. Okay, and that stuff will be due, and that also will give you time, okay, to work on these cases that you've got coming. Pardon me, these large assignments that you've got ahead of you. Okay, so you've got the SAP Business One, that project. Then you have the final exams, Part A and Part A1 and A2. You'll have the final exam, Part A, and final exam, Part B. All righty. And that'll do it. And as usual, I have Part A of the exam is due at the start. Part B is due at the end. Is it possible I'll sit down and do a whole bunch of screencasts? I'll do the screencasts as I go along week by week, but I don't expect you to attend, and don't expect that I'll be doing the live screencasts during those flex times. Those are flex time. It's time for your work. Okay. And don't forget, you've got some uploads that are due. So that's pretty much it as far as what I'll be doing. In fact, probably starting, yeah, uh, well, next week, uh, you'll have this pre-recorded screencast for the 16th, and then on the 18th, I'll do the very last live screencast, and I'll go back over all of this so you can have flex time, etc. Now, what that means is I'm not going to be doing a live screencast. I'll pre-record stuff for you, okay? And you'll know what you have to what has to be uploaded and what's doing all that business. But this is the time now to start to look at those two projects that you have, okay? And that's the SAP Business One project, as well as the final exam, which part A, you'll have a part A and a part A2, and then you have a part B, which is due at the end. Now, we always talk about, the final exam schedule, and so I'm just going to look at it for you here real quickly. All right. Now, it's very possible also when I do those pre-recorded scans, pre-recorded screencasts, it's likely I'm going to do more than one assignment. So I may say, okay, here's what I'm working on, etc. Okay, but don't forget to upload the work that's due. Just because I'm not having a live screencast doesn't mean you have work to do. But this is a chance for you not to have to sit through 100 minutes, an hour and a half of time. You've got that to work on. Okay. If you've had courses with me before, my tendency is as we get down to the final couple of weeks or so, what I tend to do, all right, is to give you projects. So let me say this, all right. Try to do, when you have some of these, try to do the work, but just make sure you upload it and get the workshop credits. And if you've got exams, you need to do those, get those done. Okay. And so you'll have that advantage. Let me look here for just a minute. I'm going to find out where we're at. Let's see. Our final exam is going to be on Monday, May the 14th, okay, from 10:15 to 12:15. All right, and that means part A of your final will be due at 10:15. Part B will be due at 12:15. I strongly urge you, because some of you, I strongly urge you, do not, under any circumstances, try to do part B in those 2 hours. I would look at it and I'd get these projects done. Okay? And as you go through the modules week by week, you know what you need to do and what to upload. Okay? And those files are there. I'd like you to try them. Okay? And I'll provide, I'll be doing screencasts, but it won't be, they'll be pre-recorded. Okay? So after this coming week, all of my screencasts will be pre-recorded. So I might do 2 or 3 of them in a row, post them, and say this is for, this week, blah, blah, blah. Okay, well, that's pretty much it on this one. Again, I apologize that I cannot be with you Monday morning, the 16th. That's when I do the, I do the live screencast from BBC, but I have a meeting at 10 o'clock. I don't know how long it will run. And so rather than generate a lot of confusion and rigmarole, I just said, okay, I'm going to do a pre-record and I'll post it and say, view this for Monday. Okay? Well, folks, thank you so much. I'm going to stop the share and then stop the recording and call it a day.